going over quadratic functions today. Now, if you remember, a linear equation was an equation that just made a straight line. So that would be a linear equation, and we knew how to find it from where it went through taking 2 points and finding its slope and all of that. But now, quadratic functions, quadratics, are anytime your x value is squared. So if I have, let's say, x squared plus 2x plus 3. Well, just like how we do all the other ones, how you're going to go and figure out how to plot the points is you're going to make the xy chart. I'm going to do the long version that I taught you, just to make it easier. Put your equation in the middle. So we always start with 0, nice round number. So 0 squared plus 2 times 0 plus 3, well, 0 plus 0, that's going to give you a y value of 3. So let's pick 1. So 1 squared plus 2 times 1 plus 3. Well, 1 squared is just 1, plus 2 times 1 is 2, plus 3, that's going to give you a value of 6. Now let's try it for negative 1. Negative 1 squared plus 2 times negative 1 plus 3. Negative 1 times negative 1 is just 1. 2 times negative 1 is negative 2 plus 3. And this is going to give you a value of 2. So now let's try 2. So 2 squared plus 2 times 2 plus 3. 2 squared is 4, plus 2 times 2 is 4, plus 3, that's 8, and that'll give us 11. Let's go on to negative 2. So I've got negative 2 squared plus 2 times negative 2 plus 3. Negative 2 times negative 2 is positive 4. 2 times negative 2 is negative 4 plus 3. That's going to give us 3. So now let's look at what happens when I plot these. I've got 0 and 1, 2, 3. I've got 1 and 6. I've got negative 1 and 2. I've got 2 and 11, which is up here somewhere. And then I've got negative 2 and 3. So our parabola, if I kept going, our parabola was going to look something like this. And it's a parabola. Now, parabolas right now, we're only going to work with ones that open up or open down. This one opens up, and how we tell that is that our number in front of this x, remember there's nothing in front of that x squared, so it's the implied 1, and it's positive. So if the number in front of the x squared is positive, it's going to open up. If it's negative, it's going to open down. So now we kind of just guessed, and I might have guessed really good, at where that bottom point is. And that's called the vertex. The vertex is at a point where on a graph, if it's opening up, it's going to be at its lowest point, and if it's opening down, it's going to be at the highest point. It's going to be the point of the parabola where there's symmetry between the two sides, and it's either going to be the highest or the lowest point. Let's go on. So now, obviously it's going to be easiest to find the vertex first, isn't it? And it's a real easy formula. You're going to need to have it memorized. And for your vertex, it's simply negative b over 2a. Well, when we have our parabola, we see our format is, look up at the top, y equals ax squared plus bx plus c. A is a coefficient in front of x squared. If there's nothing there, it's the implied 1. B is the number in front of x. If there's no number there, once again, implied 1. And then c is your constant. Now, for parabolas, you have to have something x squared, otherwise it's going to be a linear, straight line. But it doesn't necessarily have to be x or to c. And we'll go over that in class later, but let's go over this right now. So in order, let's have an equation. Let's take, let's do 2x squared minus 8x plus 4. Okay? So now we know that this is, 2 is going to be our A, negative 8 is going to be our B, and 4 is going to be our C. Make sure you keep the sign in front of the number. So let's go put these in. So remember, this is the x value. Whenever you plot anything on a graph, you need an x and a y value. So for x, it's a negative b. Well, that's negative 8, isn't it? And then 2 times a, which is 2, which will give us negative times a negative is a positive, 8 over 4, which is equal to 2. So our x value is 2. And just like every other equation, once we have the x value, to find the y, you just substitute it in. So our formula was 2x squared minus 8x plus 4, and all we're going to do is plug in our 2 for the x. And when we do that, we have 2 squared is 4 times 2, so that's 8. Negative 8 times 2 is negative 16 plus 4, and that's going to give us negative 4. So that's our vertex. The point that will be where it changes is 2, so we go over 2 and down negative 4. So that's the point that we know is going to be the lowest because it's opening up, because 2 is a positive number. Now back to how we solved everything. Okay? I'm going to erase the vertex. And there are examples in the book. And we're going to go back to our usual. We're going to go back to making an XY chart. So here we have x, our equation, and then y. And our equation is 2x squared minus 8x plus 4. Let's start with 0 because that's always just such an easy number to work with. Okay, so 0 squared is 0 times 2 is still 0. So these two are 0, so our y value is just 4. Let's plug in the number 1. 2 times 1 squared minus 8 times 1 plus 4. 1 squared, 1 times 1 is still 1, times 2 is 2. 8 times 1 is 8, negative, plus 4, and that's going to give us negative 2. That's our second point. Our third point, let's plug in negative 1. So I've got 2 times negative 1 minus 8 times negative 1. Remember, minus and negative are the same thing, plus 4. So that will give us negative 1 times negative 1 is positive 1, times 2 is 2. Negative times a negative is a positive. Bring down the 4, and that gives us a total of 14. Let's try another one. 2 we already did because that's our vertex, so let's take 3. We're already off of our charts at 14, so I'm not going to do any more negative numbers. I'd have to do fractions in order to keep it in, so let's just work with another positive number. 2 times 3 squared minus 8 times 3 plus 4. 3 squared is 9, times 2 is 18. 8 times 3 is 24. Plus 4, that's going to give us a negative 2. So now we have these points that we can plot. So I've got 0 and 4, 1, 2, 3, 4, and that's where it crosses your y-axis. I've got 1 and negative 2. I've got negative 1 and 14. That's going to end up way up here somewhere. Probably like that. We won't worry about that one. And then I've got 3 and negative 2. So look at how this parabola is going to look. It's going to go, it's a very, very narrow parabola, and it opens up. So now this brings us to the last section of this, and we're talking about domain. We're talking about, when we talk about domain, we're talking about possible values that could be in this parabola. Now, if we look And if we go straight across here, we cap out at -4, don't we? Not exactly the most even line I've ever drawn. So let's try and move that down. Can't do it real good. So we know that it's going to be anything below this -4 could not possibly be in the parabola. But then we look at our, that's for y, and anything above -4 is a possibility, right? So it's in the domain. So now let's look at our y's. Because the parabola is opening up and going on into infinity, even though it's very narrow, it's going to keep going on forever. So it's every number for y. So we do the infinity sign for that. So now I'm just going to recap what you need to do to graph these parabolas. Write your formula down. Find the vertex. The x value is going to be -b over 2a. That formula is in your book and everywhere on the internet. From there, once you find your x, you plug it back into the original equation to find your y value. That gives your points x and y plotted. That's your vertex. From there, go back to exactly how you graph linear equations, and that is making an xy chart and plotting the points. That's all there is to this lesson.